All right, welcome to the Explainer. So, for years now, developers have been calling one programming language their most loved, and that language is Rust. But what's all the hype about? Today, we're going to dig into what makes Rust tick and figure out why it's really changing the game for building software that's both safe and incredibly powerful. So, let's start with a number. A pretty scary number, actually, that haunts the entire software industry: 70%. This number points to a massive, fundamental problem in how we've been building, well, everything digital. So what is that 70%? Well, that's how many of the really serious security bugs. We're talking the big ones, the heartbleeds of the world that expose millions of people's private data, are caused by just one type of problem: memory safety errors. You can think of it like this: your program just forgets where it put some data, and that simple mistake can leave a door wide open for hackers. And the craziest part? For decades, we've kind of just accepted this as the cost of doing business in programming. So that brings up a really powerful question, right? I mean, what if you could just eliminate that entire class of bugs, not by telling developers to be more careful, but by using a language that makes it literally impossible to even create those bugs to begin with? Well, that is the big, bold promise of Rust. It's a language built from the ground up to solve this exact problem, this memory safety nightmare, without making you sacrifice performance to get that protection. And this image really shows you where Rust fits in. See, for the longest time, programming languages forced you into a trade-off. On one hand, you had high-level languages like Python, super safe, easy to use, but you don't get a lot of direct control over the computer's hardware. On the other hand, you had low-level languages like C. You get total control, absolute power, but they're famously unsafe. Rust just looks at that trade-off and says, nope, we're going to do both. Now, this isn't some kind of magic trick. It's a design philosophy, and it's built on three main pillars. We're going to walk through each one of them right now to see exactly how Rust pulls this off. Okay, let's dive into that first pillar: fearless safety. This is where Rust directly attacks that 70% problem we talked about. So, how does Rust do it? The secret sauce is the compiler. Think of it as this incredibly strict but super helpful security guard for your code. Before your program can even run, the compiler checks for all those classic memory bugs. It stops you from using data that isn't there anymore. It prevents two parts of your code from trying to change the same piece of data at the same time. That's a huge one called a data race. And it makes sure you don't accidentally peek into memory where you're not supposed to. And the best part? It catches all of this at compile time, which means you can write really complex, concurrent code without that nagging fear that something's going to blow up later. And that leads to this quote, which I think is perfect. You really have to stop thinking of the Rust compiler as this annoying gatekeeper. It's more like a senior developer doing a code review for you. Yeah, it's strict, for sure, but when it finds a mistake, it doesn't just yell at you. It gives you these super helpful error messages that often point out exactly how to fix the problem. It's actually teaching you to be a better programmer. Okay, so Rust is incredibly safe. Got it. But all that safety doesn't mean much if it's a total pain to actually build things, right? And that brings us to our second pillar: powerful productivity. And a huge part of that productivity story is a tool called Cargo. It comes built in with Rust, and it's basically your all-in-one command center. You want to start a new project? Cargo New. Need to download some libraries and build your code? Cargo Build. Want to run it? Cargo Run. It even generates professional documentation for you. Cargo just handles all the boring, tedious stuff, so you can focus on the fun part, writing the actual code. So what you end up with feels like the best of both worlds. You're writing code that's expressive and modern, kind of like you would in a high-level language, but under the hood, it all gets compiled down into this super fast, super efficient code that runs right on the metal. You get the great developer experience without giving up performance. It's a huge win. All right, that brings us to our third and final pillar: fine-grained control. This is all about how Rust gives you that raw power you'd expect from a systems language like C or C++. Now, this image might look a little intimidating at first, but don't worry about memorizing all these names. The big idea here is that Rust doesn't just give you one way to manage memory. It gives you a whole toolkit. Each of these pointer types is a specialized tool for a very specific job. It's all about giving you the choice and control to do exactly what you need. Let's just look at a couple of examples. First up is Box. This is probably the simplest one. You can think of it as literally putting your data in a box and putting it on a shelf in a big warehouse, what programmers call the heap. This is your go-to when you have some data that needs to live for a while, and you know there's only one part of your program that's in charge of it. Simple, clean, one owner. Okay, but what happens when you need multiple parts of your program to share some data? That's where RC comes in. RC stands for reference counted, and the best way to think about it is like a library book. The system keeps track of how many people have checked out the data. It's only when the very last person returns the book that it gets put back on the shelf. This is an elegant way to share data safely without anyone accidentally throwing it away while someone else is still using it. So, the real takeaway here is that Rust gives you the power. You get to make explicit, conscious decisions about performance and memory. You pick the right tool from the toolkit for your specific problem. And all the while, you've still got that compiler watching your back, making sure you don't do anything unsafe. So, we've got safety, productivity, and control. It all sounds pretty amazing. So, what's the catch? And who's actually using this in the real world for mission-critical stuff? Okay, let's be honest. Rust isn't perfect. There are trade-offs. The very things that make it so safe, that strict compiler, that rich type system, also create a pretty steep learning curve. People often talk about fighting the borrow checker when they're starting out. You kind of have to unlearn some habits from other languages. And yeah, because that compiler is doing so much amazing work for you up front, your build times can sometimes be a bit slower. But that learning curve clearly hasn't scared off the heavy hitters. We're talking a who's who of big tech. Amazon, Google, Microsoft, you name it. They're all using Rust for some of their most critical systems, the stuff that just cannot fail. They've decided that the payoff in safety and performance is absolutely worth the initial investment. And that really brings us to this quote, which I think perfectly sums up the whole vibe of the Rust community. It's from the book Rust in Action, and it says, "To everyone aspiring to write safer software." See, it's not about being some exclusive club for hardcore systems hackers. The goal is to give all developers the tools they need to build software that's just better, safer, more reliable. Which really leaves us with one final big question. When you look at this combination, this blend of safety, raw performance, and a really supportive community, you have to wonder, is this the blueprint for the future of software? Is this how we're going to build the reliable, efficient systems of tomorrow? I think it just might be.